Today, we're going to pull back the curtain on something that feels like magic, but is actually something you can totally get your head around. How do machines really learn?
I mean, seriously, think about it for a second. You scribble down a note, some machine scans it, and boom, it knows exactly what you wrote. How does that happen? Is it some kind of artificial brain? Is it just magic? Well, no, not quite.
The whole process is actually a lot more like a very specific, really powerful recipe. And right now, we're going to walk through that recipe step by step.
Think of this as a kind of detective story. First, we'll look at the big mystery, this secret rule book we're trying to figure out. Then we'll check out the clues, which are our examples. After that, we'll see the list of suspects, or the menu of possibilities the machine can pick from. We'll watch it make its final, educated guess. And then we're going to put it all together to predict a movie rating. Ready? Let's go.
Okay, first things first. We need to talk about the most important and kind of the most mysterious part of this entire thing, the secret rulebook. This is the perfect absolute truth we're trying to find. In the world of machine learning, this has a name. We call it the unknown target function, or just F for short. Imagine F as this perfect, godlike rule that could take any piece of handwriting in the entire universe and instantly tell you what it says. The only problem? We don't have it. We can't see it. It is, by definition, unknown.
You know, a really good way to think about this is like a teacher's secret rulebook. The teacher has the perfect answer key with every single answer to every possible question. But they're not just going to give it to us, right? Our job as the student is to create our own answer key that gets as close as possible to the teacher's real one.
So if we can't just look at the secret rulebook, how in the world do we learn anything? Well, we do it by looking for clues, and those clues, they come in the form of examples.
These clues are what we call a data set, and we'll label it D. A data set is really just a big collection of input and output pairs. So for our handwriting problem, this would be maybe thousands of images of handwritten letters, that's the input, and each one is paired with the correct digital character, that's the output. It's all evidence of how that secret rule F works out in the real world.
And this, right here, is probably the most important point. We never get to see the perfect rulebook F, ever. All we have is our data set, D. It is our only proxy, our only window into what the truth might be. So you can see why the quality and the amount of these examples is just everything.
Okay, so we've got our evidence. Now what? How do we actually do the learning? Well, that's where the learning algorithm comes in, and it needs two key ingredients to even get started.
The learning algorithm, let's call it A, is really the engine of this whole operation. It is the recipe itself, the set of instructions that takes all our data and starts hunting for a pattern, for a rule that explains what it's seeing.
Now, this algorithm needs two things to work. First, of course, is our data, D, but the second one is a really cool and powerful idea called the hypothesis set, or H. The best way to think of H is like a menu of possible answers. Before we even start, we have to tell the algorithm what kind of answers it's allowed to look for. Are we looking for a simple straight line, a really complex decision tree, a giant neural network? That menu of possible models we let it choose from, that's our hypothesis set.
So we have the evidence, D, we have the menu of options, H, and we have our searcher, the algorithm A, all ready to go. Now, for the moment of truth, making the final decision.
What happens is the algorithm sifts through every single option on that menu, our hypothesis set H, and it picks the one single rule that does the absolute best job of explaining our data, D. This one best choice is our final model. We call it the final hypothesis, or G. And this G is the actual thing we can use to go out and make new predictions. But, and this is so important to remember, G is not F. Our final model, G, is just an approximation of that perfect truth, F. And why is that? Well, because it was only built using a sample of the data, and that data might have errors, it might be incomplete. Our goal is always to get G as close to F as we possibly can, but at the end of the day, it's always an educated guess.
All right, so theory is one thing, but let's see if we can actually put this into practice. We're going to take a look at a classic machine learning problem, building a movie rating system.
So let's do a quick little quiz. I'm going to show you 4 pieces of a movie rating system, and I want you to see if you can match them to the concepts we just talked about: the inputs, the outputs, the hypothesis set, and the data set.
Okay, here we go. We've got the actual rating from 0 to 10,
all the pairs of users and movies, all the possible ways you could even model a rating, and a database with 20 million real ratings. So which one is X, Y, H, and D? Take a second and think about it.
Got your answers? Okay, let's see. First up, the rating from 0 to 10. That's the thing we're trying to predict, right? That makes it our output, or Y.
Next, what about the user and movie pairs? Well, those are the specific questions we're asking. Like, what would this user rate this movie? That makes them our inputs, or X.
What about all possible modeling rules and factors? That sounds like the entire universe of models we could possibly choose from. That's our menu of options, our hypothesis set H.
And that leaves us with the 20 million ratings. What's that? Well, that's our real-world evidence, our mountain of clues that we're going to use to learn the pattern. That, of course, is our data set, D. How'd you do?
So let's just tie this all together with a bow. You take your data, D, and your menu of models, H, and you feed them both into a learning algorithm, A. Out comes a single trained model, G. We choose G because it's our best shot at guessing the unknown perfect truth, F. And the most powerful levers we have as humans in this whole process are picking that menu, H, and picking the algorithm, A, that searches through it.
And that leaves us with one last, really crucial thought to chew on. The machine is incredibly powerful, but it's not a magician. It can only pick the best option from the menu that we give it. So that begs the question, what happens if the true, perfect answer just isn't on the menu we gave it in the first place? Something to think about.